time on pressure, right? This is on your book and thing number. Ask right on your book and thing. Right. So we decided to talk about pressure. We talked about pressure on a solid and pressure on a liquid. I'll take off all the headphones, please. Chris and Megan. Right? We decided to talk about Oh, and Megan had on her headphones. Like about 10 seconds ago. Right? So pressure is equal to force on area. That's pressure on a solid, and we said pressure in a liquid was dependent on what? Depends on its density, gravity, and depth. That's okay? Yeah, the lower you go, the pressure was what? Was greater, right? But what we said happened that pressure at the same depth. Pressure at the same depth was what? Was the same, right? So pressure at the same depth was the same. So now we're going to use something called the hydraulic lift that uses these two principles. All right. So head up again, as I said, the hydraulic lift. So we're going to spend some time on this. We have two more things to finish off this topic, right? We have this to look at, manometer, and something called a kidney principle. Right? And we're going to try and do that today. Ready? So how does the hydraulic lift work? Right, so the hydraulic lift, it works like this. Right, we have two pistons. One of the pistons is larger. One is smaller, one is larger. And between the piston, we have a liquid. But this liquid is incompressible, means you can't compress it. It'll always maintain this volume. Right? So what do you think will happen here, Ethan? When I push down here, so you're not Ethan. Ethan, come. What's the name again? Richie, Ethan, come. Right, Richie, what do you think will happen if I press down on this side? Think about it. If I press down on this side, what will happen here? This liquid, right? This liquid incompressible, so it act like a solid. So when you push down here, here will go up. So here's what the hydraulic lift can do. The hydraulic lift allows you to apply a small force here, and it can lift a large force here. Right? You'll ever saw like you went to like a garage and you're able to lift cars up, that's a hydraulic lift. And the liquid here is a hydraulic fluid. Right? And they able imagine one small man lifting up an entire car. Right? And that's basically using the same principle here. So what he does is, as I said, here you're applying a small force. You're applying a small force, and here we're obtaining a large force, like something that can lift a car. Right? Larger. You wanna laugh. Look at the cyber truck. It's looking just like that. Cyber truck is look just like that. Right? So a small force lifting a large force. All right? That's the principle. So do a little sketch, and I'm gonna give you a small, and I'm gonna show an example that will explain all of this. Right? This is a popular thing that I like to give an example. Right, let us do online, let us do online video, put online boy. Elena, you're online, Anya. Okay. The cover secret castle is on castle. Alright, ready? I'm gonna give you a small note on this and then we're gonna do some calculations. And all the elements give you access to all the visuals, right? All subject. So if you have no work, the right? I think people have to use it now. You'll fix it. Claro, I'll use some of these stuff. Right, take a small note. The confirm, what mean confirm my language? I ain't talking English. Signally, the answer in the airport. If I talk English. Right, take a small note. The hydraulic lift. The hydraulic lift uses a principle of pressure at the same depth pressure at the same depth put in brackets horizontal depth, put in brackets horizontal pressure at the same depth is equal. Pressure at the same depth is equal. Pressure at the same depth is equal. Full stop. Full stop. It allows for a small force. It allows for a small force to be applied. It allows for a small force to be applied on piston A. It allows for a small force to be applied on piston A. A small force to be applied on piston A and large force and a large force to be obtained on piston B. And a large force to be obtained on piston B. First up, it works as follows. It works as follows. So I'm going to show you a small example here to show how it works, right? It works as follows. Ready? So watch this here. So let's take a look at an example. This is piston A, this is piston B here. So on piston A, here's what we know. On piston A, we know number one, we know the force on A is 10 newtons. And number two, we know that the area of A is small, right? So let's say 2 meters squared. Right? On piston B, all we know is this. On piston B, all we know is we know the area. we know the area of B is, let's say the area is, let me say about 20 meters square. All right, let's see how we're going to get a force bigger than 10 newtons here, right? So here are we doing? We are applying a 10 Newton force here, and we're going to get a larger force here, bigger than 10 newtons. All right, and here's how it works. So if we have force on area, what we could find is on pressure. If we have force on area, we can find pressure. So we can find the pressure at A. Pressure is equal to force, correct SI unit, area, correct SI unit. So the pressure is equal to 5 pascals. Correct? What did we say earlier about pressure at the same depth? Pressure at the same depth is equal. So if the pressure at A is 5, then the pressure at B is what? 5 as well. That makes sense, Pini? So the pressure at B is 5 pascals. That's okay? What do I want to find, Lorraine? I want to find the force here. So how do I find the force at B? Force is what? Pressure is force on area. So force is what? Pressure by area. So it's pressure by area. So pressure 5, area 20. 100 newtons. Right? So a force that is 10 newtons in this system could lift something 10 times as large. Are you okay with that? Yeah? So most important thing here, pressure at E and pressure at B equal. Okay? So I want you to know that, right? That's the most important thing. Pressure at A is equal to pressure at, okay, copy that down. Right? And that's the way the hydraulic lift will work. Right? I have a quick question. Anybody can answer. Suppose I wanted, right? Suppose I wanted to get a larger force. What I could change? There are two things I could change. I could change the pressure, what somebody's telling them. Area. I could make this area smaller because you don't want to have to do more work, right? You don't want to have to apply a bigger force. But if I make the area smaller, I'll be able to lift a larger force. That's okay? Good. Copy that down. Let's do our 2 examples of this and move out of this, right? Excuse me, also, like that. Yeah, so also the wood gamma. No, but they'll complain. But I never like so who the control how exactly that 10%. Yeah, okay, yeah. But if we do it now, I know what the one remark. Ready? Example one. Let's try one. Find the mass of the car. Find the mass of the car. Wait, let me just make sure I know how to do that. Highest convert this star mass. Highest convert a 4-star mass. Divided by gravity, right? Right? Because remember, force is like weight, right? Remember, F is equal to mg. Right? Just remember that. Right? So I am not asking for the force, I am asking for the mass, right? So you gotta divide. All right. Anyway, find the mass of the car that a hydraulic lift. Find the mass of the car that a hydraulic lift and that a hydraulic lift can lift. Given the following dimensions. Given the following dimensions. Right? So you want to figure out the mass. So the force on A, 15 newtons. The area of A. The area of A is 5 meters squared. And for piston B, for piston B, the area of B, right? The area of B is 150 meters squared. Right? So all I want you to do is just like this, but I want you to find the mass amount. Find the mass. Okay. At your level, got it. Right? All the time. Hardly ever use my phone. Right online, message your answer. Take your time, follow the same steps. Yeah, look out that fast. But I'll be topic in the group, right? Yeah. They're waiting on the elements as well. Check it out. Pero daw check the topic on the mechanics. Right, we have all those questions to do it. Or they put them up one by one. Kailan message answer? Para witness some more answers online. Right, with G and Chiron, remember your value has to be in kilograms, right? I don't want the force, I want the I want the mass, right? Ready? Remember? Alright, ready? I'll get you. Right, we'll pick on. Now you pick on Nathan. What you got, Nathan? The one I give you, Nathan. Come on, you got. Shut the light. I'm gonna sleep in the back there. Come, you do the whole thing. Come on. If I give you a force and area, what's the first thing you can find? If I give you a force and area, what's the first thing you can find? If I give you a force and area, you can find what? It's still on the board, right? So you can find pressure at A. What you do again? What's that? 15 by 5, right? Force divided by area. How much is that? 3. And that's the same pressure at what? And that'll be the same pressure at what? Y. You remember why? Because y is equal. Y is equal. Megan, you can remind him there. Y is equal. Next, Megan, y. Take the wrong thing. Y again. Same what? Same depth, right? Same depth, same horizontal level. Right? And so we know the pressure at B. So what will be the force at B? Right? Remember, force is pressure by area. So it will be pressure, which is 3 by area, which is 150. So that's 450 Newton. Okay, then do I stop there? No? What to do? What to do? Nobody want to help you? Divide by y. You know, do we listen, boy? Look at right here. Mass is force divided by gravity. Right? And I asked the mass. Right? So the mass will be 450 divided by 10, which is 45 kilograms. That's okay? So therefore, this force can live a mass of 45 kilograms. Okay? Right, good job, Jaydan. Right, Serena? Sorry, a little mistake. Sheila? Pandina is sorry, a mistake. All okay? Yeah. Right, China's here. Rajiv. We must admit. Try that, please. Try that on the board. Right? You all see the hydraulic lift? Here's the shape. The shape. What are they? Right? You have 6 minutes. Do that later. Oh yeah, 6 minutes. Let's work on that part. So, no, mine was up. Yeah. All right, guess what? You all do need a diagram, right? Because you know what it is, right? I just go and try and zoom in the underneath. At the best I can zoom in there, right? Oh yeah, work this out. You know, like what when I bring it bring on the board, bring some people on the I'm a claim. And it's just one. Sorry? That's great. Area wouldn't be Q, area will be square, right? One of the main ones. There you go, no, either. One of them covered. Yeah. Come on the board. The board, how it is. We got sure? Huh? So you're taking your time. Part one, what are you asking for in part one? Pressure, easy, right? Part one should be easy. Part two, what is the area? Right. So they give you a force and they want you to find area. So what else you need? They give you a force, they want to find area. So you need what? pressure. And what we know happens in pressure here. Yeah? What we know about pressure in piston 1 and piston 2. Same. Right here down. Yeah, let's pick up on those little things. Very simple thing, right? So the pressure here and here is the same thing. Okay? And then you find the area. Yeah? So what's that? No? Alright. Come on the board. You pick one time. All right. Online, just now, I don't much anything of it. Right. So part 1, they asked us to find. Part 1, they asked us to find part 1, they asked us to find pressure. So pressure will be equal to force over area. So that will be 1000 over 0.02. How much is that? Give me standard formula. 5 by 10 to the 5. Can I walk up in here just so? Walk up in here. That way you're doing enough, just walking at last. Yeah, get it. Get to stick it out. Right? So pressure is equal to this, right? So P1 is equal to 5 by 10 to the 5 Pascal. Are you okay with that? Right. Now, I heard you all complaining there. Somebody telling me you're making subject of the formula wrong. Right? So please remember, if you want to make A the subject, I showed you all the little triangle. And what number I showed you all this? Pressure, force by area, cover the A. So area is force and pressure and force, right? Or you can cross multiply here. So area is equal to pressure over force. Sorry. If after? I write it bad. Sorry. Sorry about that. Right, yeah, so it's force on pressure. The force was what again? 10 to the 5. And although I had 10 to the 5, it's the same thing as 1 by 10 to the 5, right? So this will cancel and you'll get 0.2 meters squared. That's okay? And when you're writing your value, write the unit as well. Okay? All okay with that? All right, next. All right, so I'll put the finish thing last week. So head up, Academy's principle. Academy's principle. I'm not going to show the video with the man. Hold on, and I'm not going to find the video. Hold on over there. I just looking for the video here. Oh, give me that. And what you see over there? So let me make any sense. The guy might be naked, but it will be a naked. Now the man who run across the field and run around and you reach up. Yeah. Remember that? And we had a story. He just made and he run out and he figure out something. And he say you're good, and he run around, he build it naked. You know? But you feed him too. You don't remember nothing.
When you have a beaker filled with water and you put your index finger inside it, you'll observe that the water level rises slightly. You put in 2 fingers, the water level rises a bit more. Now when you put in your hand up to the wrist level, you'll see that the water level increases significantly. The ancient Greek mathematician Archimedes observed something similar when he got into a bathtub. When he got in, he realized that the level of water went up. In both the cases, you notice that the water is displaced by the object that goes in. Keep this thought in mind. We'll come back to it soon. In our previous videos, we'll see that when an object is placed in or on the fluid exerts a buoyant force on it which acts upwards. The Archimedes principle goes just one step further in saying that the buoyant force applied by the fluid is equal to the weight of the displaced fluid. We can take a simple example to understand this. Take a 5 kg solid object and suspend it.
Oh, I see. So there was the one where they explained what it was, right? But here's basically what here was the problem that the king had. The king found, you know the story before? So it had a king, right? And he wanted a particular crown made, right? But he wanted to make sure the crown was pure gold and pure jewels and like. So he was worried that the guy was making it without smarting, right? So what Archimedes decided to do, because the crown was shaped kind of odd, right? Is that crown? Right? He wanted to find a way to work out particular quantities like gold he wanted, but it wasn't uniform, right? But Archimedes didn't know at that point in time what to do, right? But then he recognized while he was creating one day, he recognized that if he were to, when he went in patterns, the water would rise by a particular value. If it comes out, it'll go back down to the original. So he recognized that this change in volume here had to do with or was similar to force being exerted on him, right? So what he was able to do was to come up with this nice experiment. You did that in school, like in the principle, no? Right? But here's what he did. He was able to show that if I take a displacement can, right, you fill it with water, and you place an object in it, that object will displace a particular amount of fluid, right? And what he observed is that the weight of this fluid was equal to upward force acting on the object called the upthrust. You'll ever take a balloon and try to push a balloon or go down in water. What is happening? It's come up, right? So the reason it's coming up is much of a force acting on it. And that force is called the upthrust, right? And now that Archimedes was able to work out the upthrust, he knows the upthrust here, and he knows the weight of it, and he was able to do some calculations and find the exact volume, right? And I'll show you later on how we did that, right? But this is Archimedes' principle here. Whenever an object is submerged in water, it will displace a particular volume. And the weight of that fluid is equal to the upthrust. That's okay? That's the principle behind Archimedes' principle. All right? The weight of fluid displaced is equal to the upthrust acting on the object. That's okay? All right, so before I give you a note, just catch up. Right, but that was the principle. There's a nice little video, look at the thread. Where they give you the full story. Right, so as I was saying, remember the upthrust. Online, you'll understand this principle here. Nerissa, are you okay with us? That the upthrust, that upward force, was equal to the weight, yeah, is equal to the weight of fluid displaced. That's now we'll put some formulas into it, right? When you're ready, with a small note. By the way, all the things in the handout as well, right? So next time you take it out, go back to the handout. That was not your likely right. Monday. Right, take a small note. Academy principle. Ready? Academy's principle states that for an object, Academy's principle states that for an object that is wholly WHOLLY, for an object that is wholly or partially, for an object that is wholly or partially submerged in water plus fluid. It don't matter. It doesn't have to be water, right? For an object that is wholly or partially submerged in water slash fluid, but it can happen in air as well. For an object that is wholly or partially submerged in water or fluid, it's obtrust, it's obtrust, it's obtrust, or buoyancy force, it's obtrust or buoyancy force is equal to the weight of fluid in displacement. Is equal to the weight of fluid in displacement. Is equal to the weight of fluid in displacement. Right? So basically, obtrust equal to weight of fluid in displacement, right? Right? And there are three things that we need to note. If I were to give you an object, right? And I said that that object, right? I wanted that object to sink in water. Right? What are the two forces acting on this object? What are the two forces acting on this object here? Obtrust is one. Let's call that U. And weight. So the two forces acting are weight and obtrust. Right? Suppose I want this object to sink. So it's a submarine. It's a block submarine. Suppose I wanted this to sink. What do you think must happen?
It must be a just
I have to make the weight greater than the obtrust. How would a submarine do that?
something that's taken.
Taking water. Very good. So if you want something to sink, you will let its weight, W's weight, right? You would let its weight and use obtrust. If you want something to sink in the water, you want the weight to be more than the obtrust. Suppose you want something to rise, right? You want this object here to go up. Yeah, you want it to go up. Which one would you make larger? Obtrust. Obtrust bigger than weight. And lastly, if you want an object to float, that'll be equal. Very good. Right? So the weight equal to the obtrust. So if you want something to float, right? Or you observe something floating, then it's obtrust and weight equal. Right? You want something to move up or rise in the water, obtrust is more than the weight. Here, weight more than obtrust. Right. Ready? All right, and so, right, so I just want to show you how to find uptrust if you have to find it, right? If you have to find uptrust, we said uptrust is equal to weight of fluid displaced, right? How you find weight again? Mass by gravity, right? So what do we need to find weight of the fluid? Mass of the displaced fluid, right? So in order to find weight of the fluid, right? In order to find weight of the fluid, right? We need mass of the fluid by gravity. Correct? Yeah. But suppose we do have mass. Suppose we do have mass. Suppose we do have mass of this. Is there a next way that we can find mass? Suppose we had, because it is a liquid, what we can find from that liquid? There are two things that we can find. No, not that special. We can find the volume, right? So we can find the volume, and well, we will know the liquid, so we will know the density. So if you have density and volume, I just find mass. But remember, you have density and volume. I just find mass. How? So this formula learns. Density is equal to mass and volume, right? So mass is density by volume. Okay? So therefore, uptrust, if you don't have this, you can just take the density of the fluid by the volume of the fluid and multiply it by gravity. That's okay? So if you don't have mass, you can use this relationship here, right? You can use this and find uptrust. All okay with that? Online, are you okay with us? So you could find uptrust using this or this. Right, and well, from a little video, you might remember this, that the volume of the fluid is equal to the volume of the solid. Right? So based on the volume of the solid you put in, the volume will be the same thing. Hi, Chevat, are you okay online there? Serena?
Thank you.
Alright, let's see if we can try a calculation now. Alright, let's try this next. Right, if you can't see, take a quick. Let's try this, please. This one right there, so. Right, the first thing I like to do on write down all the important stuff, right? Right, write down the mass, the volume, so the seabed flow, you might need that, but write this down. Right, and then find the upthrust. If you look underneath, it has some values, right? Underneath there's density of the seawater and gravity. Huh? Oh, put it on, that's my okay. Oh yeah. So take a little read, and what they want you to find is the upthrust, right? You only know two formulas for upthrust, right? So either you use this one or this one. Check and see which quantities they have. Do you have mass of the fluid in this place? It give you mass of the fluid? Nah, it didn't give you mass. What material? Sorry, what fluid it's in? It's in salt water, right? So do we have the density of salt water? Yeah, they gave us that down there. What else they gave us? Did they give us the volume of this liquid? Sorry, the volume of the solid. Yeah, they gave you the volume and they gave you the mass and the volume. Right? Get everything in here. All right. So when answering the question, the first thing you identify what you have to find. Right? We have to find upthrust. Then hopefully somewhere in your mind, you'll remember that it only has these two relationships here. Right? So check and see if you have mass of the fluid. If you don't, you use this one here. Right? So we know the density. We had to figure out how to get the volume, and we have gravity. And that's it. Okay? Right? Part 2 might be a little tricky. I'm still to come up with. Part 2 might be a little tricky. Part 2 or 3? Part 3 or 3. Right. Take your time. Right, so as I said, highlight all the important things there. They give you the mass and so on. Look out the upthrust. by the way, when you're working it out, make sure everything in the right SI unit. Make sure density in the right SI unit, make sure gravity and volume. Right? If it's not in the right unit, you have to change it. Gerard, you follow what's going on? Gerard, you there? Yeah. Option the one. Force. Right? If you look at the diagram, there are three forces acting, weight, upthrust, and the normal reaction, cut that force. Okay? So when they ask about normal reaction, here they're talking about here. Give me a few minutes again. 1 and 2 should be okay. Big on you have part 1. You part 1. Oh yeah. Huh? 3, 2, 5, but we don't need it. You don't need that right now. So you don't need that one. Right, let's just make sure you're doing part 1 correctly. Megan, what's the formula we're using for upthrust? Upthrust is what? Still on the board. The formula is still on the board there for upthrust. Right? But if you look at the two formulas there, which one we using? Mass by gravity or density by volume by gravity? Some we use it. And we're gonna set which one we use in about 5 minutes. So. Yeah. Which one we use it? Right? We're using density of the fluid by volume of the solid by gravity. Density is 1150. Volume was 0.2. Right? Remember the volume of the submarine is the same volume into this place, right? By gravity. How much you all got? 2300. Right? So we know the upthrust. We know the upthrust is 2300. And the question said that the reaction force is 1800. The question is, how we get the result on downward force? You have to subtract. Very good. Right? City just said that we have to subtract. Very good. But what we subtracted? Missing a force. Chris, what are you missing there? What's the diagram? We have the reaction force 1800. We have the upthrust 2300. We don't have the weight. How you find weight? Right? And the mass is 480 and gravity is 10. That's all. Yeah, you have the weight and you have the 2 on top, so you have to minus them now. Right? So the downward force is equal to 4800 minus 1800 minus 2300. What you get is? The question gave you 1800. The answer is 700. Alright, part 3 is the hard part. Let's see a little technical thing. So right now it has 700 newtons acting on the submarine. What must happen in part 3? It's simple, but you have to think about it, right? Simple. Alright, online. I need some help here. I want to pick somebody online. Gerard, not paying attention. Gerard didn't message. Let me see who to pick here. Pandina, you there? You'll think about it, huh? So in order to rise to the surface, the submarine, have I told you about rise, right? In order to rise to the surface, the submarine must expel water, right? From the ballast tank, right? Thereby reducing its weight. Calculate the mass of water it must expel. So you have to figure out how much water it has to expel to the sheet. Yeah, Vandina, any ideas? What have I then? What? More than? I want to say that's one. Anybody else? Anybody else? We had to get the mass. Right now, what is happening on this submarine? A downward force, right? Of how much? So for it to go up. 23 from the 48 nano. Easier than that. So right now we have a downward force of 700 on it, right? But you wanted to do what? Right, what you thinking there? What you have to do, you want to go up. Right now, upshot bigger than, sorry, weight bigger than upshot. But you want, right? How are you doing that? Okay, I've heard one answer so far. I'll comment if it's right or wrong. So, Pandina, what's your guess? Finally, I'm here, guess. No guess? Williams, any guess? None? Javi, what's your guess? None? So think about it. Do you want the downward force to be 700? No, right? It's somewhere. How many we take down? That's all right. Come on.
It's 700 newtons.
Right.
Right. Divide that by 10.
Right.
Right. So we're getting base.
Right. You get the mass.
Yeah. So I'm 78.
Right.
So like 71.
Very good. Right? Right. So here's the problem. Right now, the downward force on it. Right now, the downward force is 700 newtons. So it means it has 70 kg too much liquid in it. So it has to release 70 kg plus something because it's 71. Right? So basically the answer is it has to release more than 70 kilograms of water. That's all. Right? All you need to do is to get rid of 700 newtons of water. How you getting rid of 700 newtons? By removing 70 kilograms. Right? 700 divided by 10 is 70. Right? That's the amount of water it has to get rid of in the tank. Right? But for it to go up, it has to lose like 70 cents. Yeah, no. Right? So in order for it, calculate the mass of water which must be expelled, right? The mass of water is more than 7 kilograms of water. What would happen if it just dispels 70? The upshot will be equal to the weight, eh? And so it will flow. So nothing wrong with putting 70 as the answer. Right, but it'll change a little because the weight and the upshot will be equal, the other is 23, so that'll lose a little bit. But for now, it has to lose more than 70 kilograms. That's the answer. Okay? Right, so next week, what we'll do a summary on mechanics, right, before we start the paper. So Aidan can learn all the formulas of mechanics, right? All right, online. So that is it there for today. Right, next week we will continue with this, a review, and then we start mechanics. Sorry, start to. Right, you want to log out?